Thank you for following along for another episode of Forgotten Gear Restorations, where we're going to tackle this little lunchbox amp. This is a Paul Reed Smith MT15. It's one of their signature amps. It's from Mark Tremonti, the Italian stallion inside of Creed. Guy's actually a great guitar player. This amp has everything you need, well, except for reverb. But who needs that when you're playing stadiums and you're getting that slap back off of those mullets? That's all the dimension you need. Just explore the space. Thank you for liking and subscribing and doing all that stuff. Bye. Dustin. The rest of you goons and mutants out there, top of the morning. Slightly overcast day here, and I'm loving it. Why? Because it feels like there's a seasonal change in the weather patterns. You don't get that here in California. You got to go back to my home state, down with the swamp people, if you want the cool breeze to start coming in, if you want what they call a cold front to sweep through the area. But, until the weather in California becomes perfected, that's as much as I can expect, right? So, Dustin, this is your Paul Reed Smith MT15, no doubt part of the Signature Series amps for our old Mark Tremonti. So I like it. All right, guys. What's going on with this thing? Well, let's pretend like we know nothing and just plug her in, go through the functions, and observe. So I'm debating as to whether or not I'm going to use a guitar or the signal generator. Old Ginny, as Brad would say. So, I'm actually going to get a guitar out, man. Why not? Warm up the old finger. So, all right, next shot, I will have that set up for you. Bye. All righty. We're going to go for a warm up on a current limited supply. So, let's engage. And then we'll power her on. Probably little guitar noises you're no doubt going to hear. All right, now, Dustin, I have set my variable isolated AC supply to 120 wall volts, and that's what she's going into. And then we have the current limited supply in effect as well. That's running in series. So let's just see if there's an overdraw condition with respect to current. So we'll get her going. Okay. Oh, look at that. We have some LEDs. A delight. An ominous delight. Let's get this light off so we can maybe get another peek at them. I would say all your tubes, including the preamp, are red plating. All right, so let's see what she's gonna do. And just a very faint glow. For an amp that's running a pair of 6v6s, I would expect a little bit more. Maybe she's cold. Now, on the rear panel, there is a switch that says, "Yea, verily, verily, if you flip me down, I will be running at reduced output." So it's in the highest output setting. So there's that, just a very faint glow. So let's see what she's gonna do. Let's see. Let's start off with clean. Look at that. How clever. Damn it, PRS. You got me. That's quite clever. Is there anything there at all? Getting any output. I got nothing. It looks like it's not even conducting. As a matter of fact, let me show you guys a shortcut. And I'm going to move the camera for this. So she's not even conducting, and that's what I was concerned with when I was giving you the little rundown on what the current limiting bulb is indicating. So hang on. Okay, so this is what I do for you guys with your gear. I'm not really doing it for you, I guess. All right, now, let's see. This is obviously a variable power supply. This replaces the wall outlet that you would typically plug into. What's it do? Well, this one is isolated. It's not grounded. So if I'm working on a scope that has like, I don't know, I'm working on like a 9 kilovolt supply. It's gonna protect me from some other bits of gear that I might be running that aren't grounded. Some old vintage test gear, for example. It's gonna protect me and the gear, coincidentally, because sometimes the test gear you're using can actually endanger the gear you're trying to service, just in layman's terms. But with respect to the amp stuff, what we do is this. All of your old vintage amps are set up for 110 volts. Did you see that? And this little supply is really cool because I can hear what your amp should have sounded like back in the days. Using this, you could literally turn back time with this dial. But these days you're really looking at 115 to 125 or even 130 in some places coming out of the wall. So I like to get you guys set up and tested at 120 volts so that if you're playing a club with a spicy outlet, that your amp will not end up being overbiased. So having said all that, just throwing some physics into the equation, you don't even need to pull out a multimeter. You don't need your oscilloscope. You don't need anything if you just have this little bit of gear. I don't need to open up the chassis and kind of put myself in danger by breaking one of the high voltage lines and putting my meter in series with it to look at current. What I'm going to do now is I'm going to determine whether or not the power tubes are conducting without doing anything else. It's very simple. All I'm doing is plugging it in. Now, the amp is in standby mode. And what does that mean? Let me do this. This is fresh and clean from the start. With respect to what I said about physics, current and voltage have an inverse relationship. When one goes up, the other goes down. It doesn't matter which one's on which side of the equal sign. That's just the way it goes. Now, as this amp starts drawing current from the filament supply and maybe slow charging the caps, we're going to have an increase in current demand. So we're going to see an appreciable decrease in voltage here on the meter. So have a look. Maybe I should zoom in for you a little bit more. So have a look. You see it there, 120, right? Now, this is with the standby. This is with the standby in the off position with only the power on, so the thing is warming up. Boom. So we're going to lose a few volts as the heaters are heating up. Now, when I switch her in to play mode via the standby switch, we should have a lot more current draw because the power tubes will then be conducting, right? So we should see a respectable amount of voltage dropping here on the meter. So here we go, 3, 2, 1. And there's nothing. These tubes are not conducting. So now we need to ask ourselves why. So that gives us a general direction to go into, but let's not make any assumptions. So let's get this thing opened up. All right, gang, now we got to get into this thing. and have a look. I'm going to turn that light back on. I'm just rolling around. Oh, pardon me, I'm getting a phone call. It's certainly not Mark Tremonti. Well, no, that wasn't Mark or any of the other boys from Creed. Now let's have a look. We have sort of the older style construction here that they like to call lunchbox, but there's nothing new under the sun. Now, there was a time, say the 40s and 50s, when you had like companies that were Stromberg, Carlson, Heathkit, a ton, Dynaco, a bunch of other old school electronics companies that were making chassis and packaging just like this. Now, obviously, no LEDs or fancy things like that, but what I'm talking about is having a basic chassis with a lid, with a cover just like this, a ventilated cover, and even with the handle. Nothing new under the sun, but still cool. But if you're playing at a show, if Mark Tremonti is touring with these, and he helped design this, did he create his own prison? Did he? I don't know. Because if you need to do a tube change on the spot, you're in trouble. This is not like you pop a string and some guy throws a guitar to you. But this probably makes this a nice backup amp if you're going to be out there. So it looks like we have some number 2, or these self-tappers. I don't know, but it looks like there's 3, and I'm going to assume there's 3 on the other side of it. Let's see if this is a number 2. We'll see what the screwdriver says. Ooh, you got to love it when it just sinks in just right. That is a number 2. So let's see. I'm literally working with the camera nearly at chest level, trying not to bump it. I got to figure out these angles, guys. I'm trying to do something a little more in-depth for you. Because I hate to admit it, but I've started relying on long-form stuff to go to sleep. Is that sad that I'm listening to like Astrum or the Y-Files? Is it sad? We're looking for evidence of life on other planets to fall asleep to. We want to hear about that puddle of water on Mars that, because water is a solvent, we want to hear that it was dissolving, some minerals and other elements in such a way that they became edible for single-celled organisms, and then the phosphates and everything, and iron, that these single-celled organisms are actually consuming that as food, and then it's generating energy for them, and then when they expel it as waste material, that is forming other minerals inside of the water. We're looking for biosignatures to fall asleep to. I can't just fall asleep to the sound of a ceiling fan anymore. You want to know why? Because there are no crickets in California. There's no rainfall hitting the roof. There we go. There's no rainfall on the roof out here. You want to know what there is? There's roving mobs of guys driving Infinity Q cars, old ones, in old G35s that are doing donuts near the old bread factory. There's the sound of trains coming and going, which is actually kind of nice, to be honest with you. And then what else is there? The sound of damn coyotes. I went jogging in the neighborhood, and I ended up just chasing a coyote around. I'm not talking about a human smuggler. I'm talking about the actual animal. So, I'm just from Louisiana. Don't mind me. All right. What are we looking at? We're looking at a full sleeve of JJ12AX7s. And Mark is not going to be using anything that has a gain factor of less than 100. Why would he do that? Why would anybody do that? And why am I looking at the front end of the amp when clearly the issue is going to be over on the rear end where the power stuff is, where all the dirty current stuff is situated. Magnetic parts trays, people. Buy them and learn to love them. Let's see how stable these guys are. I love how PRS, like, their inventory system is pretty comical. The way they label everything. I would love to go back there and just take a peek. But I'm not going to the East Coast for this. All right. We have some 5881s here. And for JJ, you just never know what that means. Because they have things labeled as 6v6s, and really it's the guts of a 6L6 in there. Why are JJ 6v6s so stout? How can they withstand 420 plate volts? Well, it's because it's really a 6L6. Why don't they sound creamy when they break up? Well, because it's a 6L6. It's just labeled as such. Now, are there 5881s truly low voltage the versions of their 6L6 GCs? I don't know. But we're going to find out when I look at the plate voltage itself. But before I do any of that, let's get her in a better position for you guys. And I'm actually going to have to change camera angles here because I'm out of adjustment space here. Hang on. But there's a drawer here, and that's what I'm trying to not be distracted on. I didn't get any sleep last night, you guys, so please forgive me. And I'm going to need to put my peepers on. So there's a little drawer here. And this says there should be, at 120 volts, which is what we're running, there should be a 2 amp fuse. And it's going to be one of the little small guys. And sometimes you get lucky, and there's an extra in here, and there sure as hell is. So let me change camera angles again. You guys are just getting the goods. All right, here's a weird camera angle, but it's the one that you need to see. I'm going to warm up the Agilent really quick. And that is my 6.5 digit multimeter that lives on the bench. I'm going to put it into continuity mode. This is what it's going to sound like when the fuse is good. Continuity means there's a continuous path. So here's the spare fuse. That's what you want to hear. Will there be internal fuses on this one? Likely. Is this one blown? Maybe not. It's not. That's actually a good sign. So, since I have it in this position, and I got you guys looking, before I open up this chassis to do any further exploration, let's see if it's not conducting because of maybe a high voltage supply issue, like say the screens or something. All right. What if I just told you that I just filmed and spoke for about 15 minutes for nothing because it wasn't recording? What if I told you that? Well, that's what happened. I'll run you through it really quick without all the color commentary. I'll just take you through this really quick. I'm going to look at the plate voltage and the screen voltage and the heater voltage. They're all there. Everything's there. It's all there. It's all in a 430 volt range unloaded. And then going over to AC on pins 2 and 7, that's all there. It's all there. So why aren't these conducting? I'm not certain. It's getting the power that it needs. Let's see what's going on. And I also verified that pins 1 and 8 are going to ground. So there's no break there. I also verified that there's a sufficient negative bias voltage present on pin 5 of each one. So what's up? Kind of hard to know. Okay, so here are the guts. And as soon as I opened up the chassis, I was greeted by a burning smell. You have another bank of internal fuses here. I'm going to check these guys for continuity. And I'm hoping that it's just one of these guys going carbonara over a shorted output tube. But honestly, again, all the voltages are where they need to be. This is a 2019 model, by the way. So let's take a little peeky and see what's making her freaky. And we're going to dig on into this thing. Now, let me get her set up. And I'm going to grab my magnifying glass and see if I can locate that, that burning smell. Where's that coming from? Now, you guys stand by. We'll get it going. And where's the bank of fuses? Let me show you. Hang on. And you see it. See these guys here, here, and here. Where's that smell coming from? I really hope everything is just on this surface of the board. The resistors are nice quality. Is it burnt? That's flux. Okay, that makes me feel better. Super bifty. It looks like we have some super beefy 5408s for all the rectifier duties on high and low voltage supplies. But where is this smell coming from? I don't see any charred components. So that's leading me to make some nasty assumptions that it's one of those fuses. The caps appear to be sitting sideways or possessing any distorted tops. So that doesn't say that they're not bad, but it's not revealing anything obvious from a cursory inspection. So that's when we need to use tools, because we need the extra senses. Okay, so just tracing the path of this little trunk of cables from this particular spot. All of these are tied into the bias circuit. Now, it looks like there's some 1 ohm bias sense resistors there. I'm curious to see if there's continuity between one of these fuses and these guys. Perhaps on the other side. Okay, so there's 1, there's 2, there's 3. These guys are good. So what is up? What is going on in here? Damn it, Mark! Mark! Come on! Let's figure it out. Let's figure it out. You guys stand by. Let's get crazy. Okay. These are your Tungsol 6L6 GCs installed. Pardon the lighting there, but you could see. It's just a bad angle, sorry. So your other tubes are kaput. However, I want to make sure that these are stable, because it looked like the current was creeping up, but now it looks like they've maybe stabilized. I don't mind a little bit of a wiggle, maybe like a 1 volt wiggle to and fro. Same thing with the current on the milliamp spectrum. But I think those tubes, if those were the stock tubes, and this amp is from 2019, then I believe that you're looking at a tube that just fell out of its service life. Let's see. I don't know. We shall see. So there's something strange going on in your bias supply. Though it was completely stable, unloaded, look at it now. That's half power. Let me switch it to full power. Watch what happens. Keep an eye on it. Full power seems to be more stable. Now it's in standby mode. I mean, it's in play mode. So watch what happens when I put it in the standby mode. It's in standby mode now. Nothing happens. Is this stuck on? What is going on here? Is this frozen? So again, let's do half power. Now nothing happens because standby is on. What, play mode? No, there's no difference. Half power is at 390. Full power is at 390. The plot thickens. The standby switch does nothing. I'm going to get a signal in there and see what's happening. Okay, I just solved the standby mystery. You see this little thin coax wire here? The standby switch is not switching high voltage on and off. It's literally a mute switch. It's grounding out the signal off of V5. So that's lovely. So I have another problem. Oh, God. Don't let it be. Don't let it be the output transformer. So there's another problem. If you have your output section working properly, it will output into a speaker load. If it's not, it's going to be reflected back into the output transformer, or it will stay there, and you will have an audible experience. So if I run my signal generator into a disconnected speaker load, rather into an amp that has a disconnected speaker load, then you should hear it reproducing the sound out of the transformer itself. That's very dangerous. But I'm not getting any hiss. So I'm going to get you down here to listen. And I hope I'm not getting a sinking feeling. So just listen. The amp is going to warm up again. And she's pretty close to being ideally biased. Maybe I'd bring it up another 5 to 10 milliamps just to warm it up a bit. But it's on the cooler end of the spectrum, so it's fine. So, am I going to have to investigate why this thing it appears to have a disconnected speaker? I might have to do that. So listen, I'm going to turn on some relatively low signal. It's on a clean channel. If you hear a high-pitched sound coming from down here, then you know there's a break in the signal on the secondary side of that output transformer. There it is. That's all I'm going to do. So I'm going to turn her off. I'm going to try one more test. Stand by. Okay, listen to this. I have alligator clips on the secondaries. I'm bypassing the output board, or the jack board there. One of the little daughter boards. There's 3 boards. Listen. That's an open jack. Hold on. That's it. That was it. So you have a break on your daughter board, and it's actually the bias board it serves as the bias board as well. So I'm gonna pop her out. See if maybe this little guy right here is maybe has a cracked solder joint there, or maybe the trace is acting funny, and then we'll take it from there. Bye. All right, and we have the repair completed. We're plugged into the output jack. Look at that little guy. Let's do this. Take out the little appropriate tip. So Paul Reed Smith says, if you're going to run 6L6s in this pup, then only run them at 25 milliamps, 25 to 30. Well, that's crazy. Given this plate voltage, that's 10 millivolts below 50%. So why don't we just take her to, see if we can get her to 60% and just see where we are. All right. And I could hear the bias supply saying, can you take me higher? Yes, I can, little bias supply. Let me just find the slot. I'm going to leave that in there. I am not infallible. All right, so 60% is about 46 milliamps. Let's round her down to 45. This is one of those multi-turn Cermet pots. All right, that's good. So let's see how that's going to change our calculus here. All right. So that's fine. This puts us just below 60% max plate dissipation. That's nice. That's nice. All right. So let's make sure she's stable. And before I wrap her up, there's these little, oh boy. You see these little guys right here? Are these 400 watters? Or are these 600 watters? Let's see if I can find out. It's kind of hard to see. It has very faint yellow printing on the bodies of them. And maybe I'll try to get you over there, and hopefully it doesn't zoom in on my crotch. That's not what I'm trying to do here, folks. 400 volters, dude. These are going bye-bye. I'm going to replace these with 630 volt parts. This is straight out of the Mesa Boogie playbook here. So I'm just going to do this for you, dude. Bye. What am I doing now? Now, I've removed the old 400 volt caps here that were standing in the way of 390 volts-ish. That's the classic formula for disaster as popularized and socialized by good old Mesa Boogie. But instead, or in lieu of those caps, we're going to put in the highest quality caps we can. Panasonic ECQ, one guy's opinion, 0.1 microfarad at 630 volts. That's what we want. I'm going to clean up this little bit of flux there. Let's see if I can do it without making things messier than I have already, and I think I can pull that off, but it's going to be a little challenging with the camera there. Certainly. So pardon me. There we go. That's what I like. It's a little bit right there that's just making me crazy. Awesome. Now, let's get down into the biz. And some of you guys are like, wow, through plated chassis. Yes, I like it. You're going to go, you can say low and slow or make a fast pass. I did the fast pass thing. I gently rocked. Gently. You want to gently rock the bodies of these guys to induce metal fatigue. And they're going to break off clean. Then what you're going to do is add a very small amount of fresh solder. Then what you're going to do is take your solder wick and use, this is where people go wrong, you're going to use the corner of the tip there to make sure you're inside of that little pass-through or through hole thing. And you're going to clean it out. You should only see a bit of lead remaining. The next thing you're going to do is you're going to take something you're not using, and you're going to use it. You're going to place the soldering iron against this lead, not against the circuit board, just at the bottom, and you're going to heat it up, and you're going to push the little guy through, and it's going to go straight through. The little the little bits will fall at the bottom. You collect them and remove them from the amp. And then you can go ahead and make a clean installation there. And it hasn't stressed any of the solder joints or pads or through-hole plating. It hasn't done anything naughty to them. So they're happy to be in service for some time to come. And that's that. Now, you can see that the lead spacing is a little greater. So what I typically do is I'll fold one in, and then I'll make a sharp bend. So it'll be slightly offset, and that's all you're going to do. What about the foil end? You're not worried about that. You're not going to worry about that at all at this particular stage. And then, to be honest with you, with guitar amps, you don't have to worry about that at all. This is not like super sensitive test gear. Everything is plus or minus 10-20% here. So just take that advice with a grain of salt, and anything else you find online. I am not ever going to claim to know everything or to be everything to everybody. So that's just one man's experience. But I do look at things on scopes and other really sensitive test equipment. Can you locate and find the foil end of a cap through the rigors of the scientific method? Sure you can. And you'll see the noise. You'll see it on your scope. It's very plain to see which end is more quiet. But you do you. And if that makes sense to you, then go for it. There's no harm. There's no harm in it either way. So I'll be right back. All right, you see that? That's all it takes. You see a little bend there, a little dog leg. That's it. And you use the lead bending tool, so there's no stress there. Not even on the encapsulation material there. And this is the appropriate amount of standoff there that you need. Given the height of the circuit board from the chassis below, that's going to give us plenty of clearance from shorting out on what is ostensibly a painted surface under there. All right, and then let me just fix you up there, getting seasick, huh? Take a look down there. So I've secured the first cap. It's soldered in. Nice. Take a look at this one. We're coming in at a little bit of an angle there in that leftmost lead. That's going to provide some good tension. And then take a look what I did. I'm using that little bit of frog tape to angle it back so I can get the best possible angle onto those little solder pads. And I'm going to move these guys out of the way. Now I have all the space I need. All right, there it is. Just a slight amount of silicon in between, slightly canted inward to support each other. And that's about it. She's ready to roll, man. She's good to go. Boy, this could have been so much worse. So let's thank the tone gods out there that it's not going to be. And then since we changed this guy, a guaranteed port of failure, that's something you're not going to have to deal with in the future. We save a lot of money on repairs and output tubes and possibly an output transformer.